Okay, hi everyone. This is my final video for chapter 4, which is the introduction of probabilities. I know you guys are tired of me in these videos, so I'm tired of making them too. But I thought it would be important to talk about this one last thing, which is counting principles. So let's just talk about just the basic way, just one of the basic rules of counting principles. Let me get rid of that. All right, so if we talked about, the book gives us an example. If we talked about flavors of ice cream, so let's just say you go to an ice cream shop and they have 4 flavors, right? And then they have 4 flavors, they have 3 toppings, and they have 2 sizes, right? So we know that in terms of possible ways that you can have your ice cream cone or combinations, it would be 4 times 3 times 2, right? And so there's 24 possible ways to have an ice cream cone at this particular establishment. So let's talk about there are 2 ways we think about counting principles. One of them is permutations, which gives you all the different a number of different ways that an object can be arranged. The objects can be arranged, and then there's combinations, which is very similar to permutations, except for order is not important. And so there's always going to be more permutations than combinations because the permutations order is important. And so I'm going to use an example of calling the names. Say we go to a basketball game at the beginning of the game, they say the national anthem, they call all the players, they come out, they high five everybody and head out to the court, right? And so for permutations, the order in which the names of the 5 starting players is very important versus combinations where it could be any 5 players and the order that the names are called is not important. So let's talk about just the formulas that are used and then how they are calculated. So for permutations, it is, we calculate that by saying n factorial, and n, right, is the number of objects selected x at a time. So let me just write that down just so we'll write that in red because that is the rule. So n, right, is the objects, n objects are selected, and then x at a time. Okay, so for this particular situation, let's say we are talking about, I'm going to go back to my blue. I love writing blue. So we're going to go back to talking about calling the let's say that we have a basketball team. There are 12 players on the basketball team. We're going to call their names out 5 at a time, right? So this is going to be equal to permutations 12 factorial divided by the 12 minus 5 factorial. And that's going to be equal to 12 over 7 factorial. So that makes that 12 times 11 times 10 times 9 times 8, because everything after 7 factors out, right? And that is going to be equal to 95,040 different ways you can call out those 5 names, given that order matters. That is insane, right? And so if we were to do the same thing with combinations, meaning the order that the names are not called, we're just going to call these 5 names, right? That would be equal to C, 12 and 5, right? And then for this particular situation, like I said, order does not matter. So the formula would be 12 factorial, right? Divided by 12 factorial, 12 minus 5 factorial times 5 factorial, right? And that would give us the 12 factorial, right? And divided by 7 factorial times the 5 factorial. And then that is actually going to, I'm not going to do the math because I don't have enough space on this little pad, but this is 792 different ways we can call out those combination of names. And there's some really great, I'm going to write this in green, because I like to use Excel to do these. So if you're going to use Excel, the formulas, and they're given in your book too. So this is PR mute, right? And that's N and X. And if you use it for combinations, that's combin, and that's N and X. All right, everyone, I think this is helpful. I'm going to do something around license plate numbers for our discussions in this module. Let me know if you have any questions.